Welcome, friends. Welcome to the course of Metrology and Measurement. Today, my topic of discussion is the errors in measurement, and in these errors of measurement, I shall discuss these sources of errors elaborately. Previously, I have discussed about the various methods of measurement, and during these methods of measurement, various sources of errors are there, and before I discuss about the sources of error, I have already discussed the sweep concept. This sweep concept, I am repeating that, is what are the various sources of error that comes from the idea of sweep concept. That is, the sweep concept is consisting of some standard workpiece instruments, person or operators and environment, where we know that a measurement system is a mainly due to the is a comparison process in which we measure or we compare the workpiece, that is the measurement, and with a standard one with the help of an instrument. So to operate this instrument we need some person or operators, but we cannot omit the effect of environment. Now this due to the standard workpiece, instrument, person or operators, environment, various aspects are there. But due to these various aspects, some errors are also there in the measuring results. So what are these errors? Sources of errors are there in measurement, that is the temperature, effect of supports, reading or parallax errors, accuracy of equipment, application of excess force, effect of misalignment, cosine error, etc. So first I shall discuss about the effect of temperature. So temperature, we know that whenever a metal standard is maintained at a particular place, the temperature should be maintained is 20 degrees centigrade as recognized by the international body for standard and measurement. Now, if you want to increase the temperature greater than this 20 degrees centigrade, or if you want to reduce the temperature less than this 20 degrees centigrade, now due to the metal property, due to the which is called the linear coefficient of thermal expansion of the material, the metal should increase or in size or contract. So this amount of increment in length or the contact in length or compression in length follows the following formula, that is del L by L equal to alpha suffix L into del T, where del L is the change in length, L is the original length, and del T is the change in temperature, and alpha suffix L is the linear coefficient of thermal expansion, where due to the small change in temperature, if the thermal coefficient, linear coefficient of thermal expansion is very large, then this change in length is also very large. So you have to know what temperature you have to maintain during your measurement system. Uh, in your measurement office or your measurement workplace, you have to maintain the temperature of 20 degrees centigrade, because the instrument you are using, it may be either primary standard, not primary standard, but it should be secondary standard, it should be tertiary standard or the working standard. Primary standard are not used for the calibration of the your workshop instrument, but it is used sometimes for the uh, calibration of the secondary standard, and the secondary standard are used for the calibration of the tertiary standard, and tertiary standard are used for the calibration of the workshop standard. So during this calibration, your measuring office or measuring workplace should be maintained at 20 degree centigrade. But you in the workshop, when you measure the quantity, this environment cannot be kept at 20 degree centigrade always, because during the machining or after the machining, when you measure the job length, then with a vernier caliper or with a slat calipers, then there may be error due to the room temperature effect. So that means for a temperature, you are measuring a length at a 35 degree centigrade, which is far beyond the 20 degree centigrade, that is more than 15 degree centigrade is there. So your change in length of the instrument gives rise to the error in measurement. Now next is your errors due to the effect of support. Suppose you are measuring a long this metal 1 meter long beam or 1 meter long bar are there, and these bars are maintained on the two supports. Okay, so if the supports are very large, are placed at a large distance, then this may be bending may occur at the middle portion, and also to maintain the two end faces parallel. To maintain the two end faces parallel, the support distance from each other should be 0.577 into L, where L is the total length of the beam or the bar. Now next is the length. Next is the next. Next is the length of the support should be 0.554 into total length of the bar or the beam, with where it allow, if you maintain this length, that is 0.554 into total length, then it allow the points of minimum deflection. Okay, so now this first one is called the airy support points, that these 2 points distance are called the airy support points, and second is the called basal support points, where these points can maintain the minimum deflection. Now, this kind of effect of support is very important when you are measuring or when you are using a long bar or beam. Now next is the types of error due to reading or parallax error. So reading error, first I shall discuss about the reading error, then I shall discuss about the parallax error. So in case of reading error, you know that each there is some limitation of a normal scale. Suppose you are using a normal scale which is graduated like this, and in that case uh, suppose your one end is matching with this end, and other end falls between these two lines. So for a normal scale, what is the minimum distance it can measure? That is 1 millimeter, and in some cases it is 0.5 millimeter. So if you measure with such a scale, then there is a limitation that when you measure when your line of the object falls between these two marking, then you have to measure with an assumption. You have to measure the length with an assumption that you it varies from operator to operator. This is the limitation of the instrument, and if you use the precise instrument, then where the least count is very small, then you can reduce this type of error. Another thing is that reading error is the parallax error. Here you can see the example. One of the this water level, you can see that when you see the reading parallelly or perpendicularly to this uh, reading, then your reading will be exactly give you the accurate result. So 19.7 milliliter is your reading, which is accurate. But if you look this reading with an angle, due to the error, operator reading error, or due to the parallax error, which is called the parallax error, the operator looking at the scale at an angle, and due to this error the reading will be either 19.82 milliliter or 19.62 milliliter, depending upon this angle. So there is a particular uh, there is particular relationship between this angle and the distance of your measurement, that is this error is directly proportional to the tangent of the angle which makes with the horizontal distance. So today I have discussed about three types of sources errors elaborately, that is effect of temperature, effect of support, and the types of error due to reading and parallax error. Thank you.